So let us analyze this C frame which is given according to the problem. To analyze this C frame, you can able to see that the frame is symmetrical along x-axis. So we will concentrate on modeling this only on one direction, and we will apply symmetrical loading or fixed loading on the other end. So to do this, first let us create a geometry by using Creo software or any 3D modeling software. So open Creo, click new, select MMNS part solid and then click OK. Now let us create a sketch. Go to sketch, select the front plane, click sketch view and sketch plane. So the model, you can able to see that. So the model is just a frame, so which has to be moved from this location. So from here, it has a length of around 1000 and with a radius of 2t. T is mentioned as 100. So let us go to the model, create a line for 1000 and an arc for 2t. So the length of this is 1000. Let me specify this as 1000. And this is 2t, indicating that it is 200. So t is 100, so 2t is 200. So now from here, let us create an arc with respect to this. Go to arc, center arc end. From here, let us go for drawing this arc. Once this is created, now let us click OK. And we are going to use sweep option. Go to sweep, select this particular geometry. So it is already selected properly. Now go to sketch view. Here let us draw our sketch with respect to this. So you can able to see that when I tilt this, so the direction is along this direction. So let me click this. So I have to draw the T shape with respect to this. So let us draw the T shape with respect to this axis. Now let us give the dimension appropriately. So it is mentioned as 3t, which is 300. So this has to be 300. This should be horizontal. So let me go for horizontal constraint. Select this as horizontal. Next, this distance is t, which is 100. So double click this. Give this as 100. Next, this distance is 3t and this is 0.75t. So this has to be from here to here. It has to be 3t. 100 is gone here. So remaining is 200. Go to 200. So let me enter 200 here. And the dimension with respect to this, it has to be 75. So this is our T shape. Once this is modeled, then we'll click OK. So you can able to see the frame based on that. So this is our C frame, half of our C frame. So as per the model. Once this is over, let us click OK. Let's complete this model. We go to File, Save as a copy. Change this to IGS or parasolid model. So now let us choose parasolid model for this. Give the name as C frame. And now let us save the file to a particular folder. So now it is asking how to save the file, whether it has to be solid or shell. So both is checked here. Uncheck this shell. We need only solid models. Select solid model and then click export. Once this is done, so let us close this. Let us open Ansys workbench. In Ansys workbench, let us select static structural and let us import our C frame. So in geometry, let us go for geometry, select import geometry, browse the geometry to C frame. So once the model is imported, let us go for model. So you can able to see the model which has been imported. So go to mesh. So increase the sizing accordingly. Then mesh the model. So here we have concentrated only off of the model. So this side has to be fixed. So let us go select the particular surface. Sorry. Yeah. So when you look at the model, so the force is acting along this direction. So the other sides are fixed. So let us select this particular region. We go to file, go to insert, and select fixed support. So now to apply a load, let us go to file, insert, force, select this particular region. So where we are going to apply a force. This is the region we are going to apply force. Select this, click apply. And the value for this force is 100 kilonewton, so which is 100 E3. So when you apply the force, you can able to see that the force is acting along axially, but we need force along this y direction. So to do that, change the define vector to component, and in y component specify it as 100 kilonewton. Now you can able to see the right direction which is acting along this. So now go to solution, insert, deformation, total. Similarly, I need stress, equivalent stress. Now let us solve the problem. Once the problem is solved, you can identify what is the stress developed and deformation on this particular C frame. So this completes this analysis. Thank you.